day 3 of your STAAR review, and we're going to be talking about transformations. So opening up your STAAR review folder, you should have already watched the video to place your foldable for today. But again, it's going to be placed at the very bottom of page 3, and this is what it should look like again. It should be it's a flippable. So again, transformations include translations, reflections, rotations, and dilations. So I'm going to go ahead and go back to our PowerPoint. And the first one we're going to talk about is a translation. So a translation is a slide. So, and you can remember this by looking in the word translation. It has the word SL. So this is a slide. So you can, whenever you are translating anything, this is your rule to follow. So for your X value, if you are going left, you will be subtracting. If you are going right, you will be adding. So this should be X plus or minus A, comma, and then you have your Y value. So if you're adding, that means you're going up, and if you're going down, that means you're subtracting. So this is Y plus or minus B. So going to number 1, it says rectangle JKLM is translated 3 units to the left and 4 units up. Which rule represents the translation applied to rectangle JKLM to make rectangle JKLM prime? So for starters, there's a few of them that I can eliminate because it's not in the correct format. It should be X plus or minus A, comma, Y plus or minus B. So F, this is not even a type of transformation. And again, H is not a type of transformation either. I should be adding or subtracting. I should not be multiplying. Now, here I'm starting off with 3 units to the left. Now, if I'm going from left to right, that means that is affecting my X value. Since I'm going left, that means that I am subtracting. So I should have X minus 3. And then I'm going 4 units up. So since I'm going 4 units up, that means that that's affecting my Y value. Since I'm going up, that means that I will be adding. So this is adding 4. So my algebraic rule should be X minus 3, comma, Y plus 4, which means G is my answer. So going ahead and looking at your foldable, once you open it now, this is what it should look like. This is what you should have written down. If you need a pause, go ahead and do so. But we're going to go ahead and go to the next type of transformation, which is going to be reflections. So this is going to be number 2. So for number 2, we're talking about reflections again. And it says triangle DEF with vertices at D, 2, 1, E, 3, 5, and F at 6, 2 is reflected across the x-axis to make triangle DEF prime. Which rule represents the transformation? I'm going to go ahead and write, or I'm going to go ahead and pause this, and I'm going to plot my points. Okay, so I've just plotted points D, E, and F, and here it's telling me that I'm reflecting this across the x-axis. So this right here is my x-axis. So when I'm reflecting this, I'm just plotting each point the same distance away from our point of reflection. So for D, this is 1 point away from the point of reflection, so it's going to be 1 point on the other side as well. So this is going to be D prime. Then I have E prime. This is 5 points above the point of reflection, so this should be 5 points below. So that's 1, 2, 3, 4, 5. So this is E prime. And then we have F prime. This is 2 points above the point of reflection, so it should be the same distance away. And plotting this, again, a reflection in the word, it has the letters F and L, so this is just a flip. I just flipped my triangle across the x-axis. So for D, I started off at 2, 1. And for D prime, I am now at 2, negative 1. So whenever we're writing our algebraic representation, we always start off with X and Y. And I just have to, my X and Y are in the same order, so I can copy X and Y down here. And now I just have to see what stayed the same and what changed. Now, whenever you're reflecting, since I'm reflecting across the x-axis, my X stays the same, but my Y changes. And you'll see that represented here. My 2 is still a positive 2, so my X stays the same, but my 1 went from a positive 1 to a negative 1, and the way we represent that change is with the negative sign. So here's my algebraic rule, which means that A is my answer. You could have automatically eliminated C and D because these are examples of a rotation. So again, your answer is A. Okay, so looking at your foldable now, this is what you should have written down. So if you need to take a second, go ahead and do that. But now we're going to go ahead and go on to the next type of transformation, which is a rotation. So going back to our PowerPoint, we're talking about rotations. So a rotation is a turn. So this is a turn. And number 3 says quadrilateral GHJK is graphed below. If quadrilateral GHJK is rotated 90 degrees counterclockwise about the origin to make quadrilateral GHJK prime, which rule represents the described transformation? So I'm turning this 90 degrees. So this means I am turning it to the left 1 time. I'm turning this 1 time. And for this, I'm going to go ahead and do this on my paper. And for this, there's a couple ways you can do this. You can either go ahead and grab a piece of graph paper, or patty paper, or you can go ahead and just turn your paper. So it's asking for the point G. And looking at point G, we are at 2, 3. So G is at 2, 3, and we want to find out what our new point is at G prime. So I'm going to go ahead and switch over to the doc cam, and we're going to plot this. So I'm going to go ahead and zoom in. So we have GHJK. So you will be provided a piece of patty paper for this on the STAAR test. So we have GHJK. So what we can do is we can trace the X and Y axis, just like that. And I want to label this as Y and X. So I'm going to go ahead and copy. So I'm going to copy my points and connect the dots. And you want to make sure that you're labeling this. So this is G, H, J, and K. And we're going to connect the dots. So since we're rotating this 90 degrees, that means I'm counterclockwise. That means I'm turning this to the left 1 time. So I can plot my points, get my points from here like that, or I can also just take my paper and turn it 1 time. I can record my points and then re-graph them over here, but I'm going to go ahead and use the patty paper. So for G, my new point is at -3, +2. So for G, originally we had 2, 3, and now it is at -3, +2. Next, we need to graph H, which is at -5, +3. And again, that was H. Then we have J, which is at -6, +6. And then lastly, we have K, which is at -2, +4. And these are all my primes. So I'm going to go ahead and connect the dots down. So my algebraic representation here, I started off with 2, 3, and if you notice here, my X and Y, they flipped. On a rotation, my Y now comes before my X. So if you remember the rule, let me see, 1 second. Now, if you remember, whenever we started going over rotations, we had a little hand trick for you to remember. So at 0 degrees, you're starting X, Y. 90-degree turn, Y now comes before X. 180-degree turn, X comes before Y. You turn another time, 270, Y comes before X, and back to 360, X comes before Y. And that's just a little trick you can remember. And so since we're doing 90 degrees, I have 0, 90. This now tells me Y comes before X. And again, you know this because back in the question, my X and Y value are switched. My Y is now coming before my X. So back to our foldable, since my y comes before x now, I start off with xy. This now becomes yx. And now I'm just looking to see what stayed the same and what changed. So starting from my x value, I went from a positive 2 to a positive 2. So that stayed the same. But looking at my y values, I went from a positive 3 to a negative 3. And since they are not the same, to represent change here, you distinguish that with the negative sign. So my algebraic representation is now xy and transforms to negative y comma x. So going up here to your answer choices, it looks like the correct answer is going to be B. Okay, so again, this is a 90-degree counterclockwise rotation. You can use patty paper, or you can rotate your paper and get your points that way as well. So that was rotations. So if you need a second to go ahead and copy all of that down, go ahead and do that. You can pause, but we're going to go ahead and move on to the next type of transformation, which is a dilation. So we're going to go back over to our PowerPoint. So for a dilation, you are either enlarging or you're reducing an image. So if your scale factor, or if your original image to your new image gets bigger, this means you're enlarging, and that means you're going to have a scale factor greater than 1. But if you're reducing, this means that you are making it smaller, and this means you're going to have a scale factor that is less than 1. So looking at our question here, it says pentagon ABCDE is dilated about the origin to make pentagon ABCDE prime below. Which rule best represents the dilation that is applied to pentagon ABCDE prime to create pentagon ABCDE prime? So starting off, they're asking us for a couple points. So here they want us to know the original A and A prime. So I know that A prime is gonna, I know which one's my new image by the prime. So this, the bigger one, this is gonna be my new, and this one's gonna be my old, because I know this is new because it has the primes on it. So looking at A here, I see that that point is at 2, negative 2. And A prime is now at 6, negative 6. So to find my algebraic representation, there's a couple ways you can do this. You can either take your point, which is your points, and you can divide your x values, or you can divide your y values, and that'll give you your scale factor. Or you can count the sides, a straight side on the shape. So we're going to do both ways. So here we want to take our new over our old. So our new x value was 6. Our old x value is 2. And 6 divided by 2 equals 3. So this is telling me my scale factor is 3. So that's one way you can do it. So another way you can do it, I'm going to do this now in, let's go with red. So another way you can do it is by counting the sides of your shape. So again, it's the same thing, your new over old. And the way you can also remember this is the word no, but going down, so no. So my new side length was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's 12. And then in my old side length, this was 1, 2, 3, 4. So I'm going to take the new length, which was 12, over my old length, which was 4, and 12 divided by 4 equals 3. So this means I am multiplying my x value by 3 and my y value by 3. So my new algebraic representation is 3x, comma 3y. All you're doing is putting your scale factor in front of x and y. That being said, our answer here will be G. Okay, so looking at your foldable now, this is everything you should have written down. So if you don't have everything, just go ahead and pause and catch up before you move on. But we're going to go ahead and now look at the last page of our foldable. So we're going to start off here. So we're going to be guessing the transformations. And we've kind of already discussed what each of these mean. So whenever we translate something, that means we are sliding it. So we are just sliding the image. And again, you can remember this by SL in the word. And then we have a reflection. Now, a reflection is a flip. So we're flipping this across either the X or Y axis. And then a rotation, I am turning something. So I'm turning something. And then a dilation is I'm either making something bigger or I'm making something smaller. So this means I am multiplying my X and my Y value. Okay, so looking at number 5, we're guessing what type of transformation we're talking about. It says triangle TUV and its transformation to triangle TUV prime are shown on the coordinate grid below. Which transformation to triangle TUV is represented? So A says triangle TUV has been dilated to make triangle TUV prime. Well, the size of my shape did not change, so A is incorrect. If we're talking about triangle TUV has been reflected across the y-axis to make triangle TUV prime, well, here's my y-axis. So if it were reflected across the y-axis, it would be a mirror image of each other. So all my points would be the same distance away from my point of reflection. Right here I have U 2 points away from the point of reflection. For U prime, I have it 6 points away, so it is not a reflection. And then for C, it says a triangle TUV prime has been rotated 90 degrees clockwise. So if it were a rotation, that would mean it would be turned. All of my points would not be facing the same direction. So it is also not a rotation, but it is a translation. I'm just sliding my image over. So D is my answer. So now going ahead and looking at your foldable, this is what you should have written down. Let it focus. So this is what you should have written down in the top foldable, and for the bottom foldable, this is everything you should have written down. So again, if you need to copy that, just go ahead and pause it. And again, there's the top. So going through my foldable again, our types of transformations are translations, reflections, rotations, and dilations. So again, this is going to be you're going to glue this at the bottom of page 3. But that is it for your 4 transformations. So go ahead and complete your assignment for today, and we'll see you again tomorrow for day 4.